interested to present on poultry vaccination and the current status and future prospects. Before I proceed, I would like to thank the organizing committee for inviting me to this webinar series. So my overall content of my talk today is going to be on the principles of disease prevention, advances in poultry vaccinology, future prospects of recombinant avian vaccines, and some issues and challenges of vaccination in poultry. As we may know, I'm probably is the same all over the world, as well as in Malaysia or in India. We have a lot of different poultry management settings, whether it's closed house systems for broilers or for layers or breeders. In Malaysia, we also have the open house systems. Okay, the open house system mainly for the layers, and we also have like small farmers. We call it like backyard farmers that rearing like village chickens. All of them are having different issues with different management, with different disease challenges. So when it comes to disease challenges, these are some of the disease challenges that threaten the poultry flocks all over the world. They can divide it into virus, bacteria, parasites, or fungal. You probably have learned a lot of viruses and bacteria and parasite and fungal disease that can affect poultry overall. And also we also have non-infectious disease, which mainly like management problem, infectious diseases, or something like accidental things. These are some examples of common viral pathogens that threaten avian health. I'm not going to read all, but this is, I believe it would be the same geographically all over the world. The challenges, we have infectious bronchitis, we have Newcastle disease, avian influenza, infectious laryngotracheitis, fall cholera, and a lot of other viruses that are threatening the avian health. And all these diseases have a lot of impacts on the poultry industry. As you may know, that poultry industry is one of the biggest livestock industry in the world. Okay, when disease affecting the flocks, it would increase the flock mortality, leads to the poor productions due to reduced weight, reduced egg production, especially for layers and broilers, high feed conversion rate, and poor quality chickens in general. And on top of that, all of these will lead to severe economic impacts. And some of the diseases have zoonotic potentials like avian influenza. So when it comes to controlling viral diseases, there's a lot of challenges that we have to face in controlling viral diseases in avian and poultry. When it comes to agent, some of the agents threat to various species of avian. Some agents are zoonotic in nature, so you have to face it differently. And then some of the agents are mutate constantly with variant strains. They become more virulent, extended host range, and they are able to escape the current control system, which is the drugs or the vaccines. And this disease spectrum causes a wide range of diseases, from mild to acute, persistent infection, concurrent infection, latent infection, as well as immunosuppression. Different pathogens will lead to different disease spectrum. Some disease can lead to immunosuppression. Some disease can even become latent. For example, like herpes viruses, or some concurrent infection with other things which amplify the problem. Although when they are by itself, they are not causing so much problem. And management issue is one of different things. Like if you are having a multi-age farm, you are higher tendency to keep the virus or the pathogens in the farm. And intensive with high stocking density will increase the transmission rate of a disease or virus in the farm. And for control and preventive measures, it is quite difficult to diagnose, especially those who are subclinical and with persistent infection. Some disease are difficult to control due to poor vaccine-induced immunity. I will talk more about this after this. And vaccination can also complicate diagnosis, especially when it comes to serology, or sometimes in molecular detection, it's a bit difficult unless you have a DIVA strategist. And when it comes to bacterial diseases, some bacterials, the challenges in controlling bacterial diseases is for example, like resistance to antibiotic is high against selected bacteria in poultry. I'm not sure how about in India, but in Malaysia, we have a lot of farmers abusing the use of antibiotics. They are using antibiotics as a scheduled regime rather than when there is a problem. Some bacteria develop multi-drug resistance, such as MRSA or VRE, and also lacks of antimicrobials with new targets or mechanism of actions. We need to develop a much more narrow spectrum antimicrobials. There is no single non-antibiotic products or probiotics like probiotic, phages, prebiotics, organic lactic, then can fully replace antibiotic. We are trying to look for alternative, but none of them is not as good as antibiotic itself. We need more fundamental studies on the mechanism and also innovation to improve efficacy of non-antibiotic products. And we also need to develop more vaccines against foodborne bacterial infections. So with all diseases, all these challenges I'm talking about, there are the three principles of disease control. First of all is biosecurity. Second is immunization. And the last resort is treatment. Okay. But I'm not going to talk about biosecurity and the more smart treatment, but I'm going to talk more on the immunization. But you have to keep in mind that vaccination is always a complement to biosecurity. Biosecurity comes first. You should always like perfected biosecurity, then you complement it with vaccination, not the other way around. So immunization in general is a prevention of disease through vaccination. The role of vaccines is to stimulate production of antibodies and other immune functions to fight and neutralize disease pathogens. The vaccine objective is to stimulate immunity and protect animals from diseases, whether by providing them with sterilizing immunity, which prevents infections or removing pathogens from the host, or disease immunity, which it prevents the development of the disease. Some some vaccines will keep the virus. The virus can still replicate in the host. However, it prevents the development of the disease and prevent the mortality of the flocks. And the vaccine is also able to have a blocking immunity, which prevents virus from sheddings and transmission of this disease. This is one of the important part of the vaccine. If you are able to reach to that stage, which is one of the most ideal vaccines. And also is to protect progenies via production of maternal antibody. This is important for breeder farms. So when it comes to vaccines and vaccination, an ideal vaccines should, this based on Royal Society, the guidelines of Royal Society reports on infectious disease of livestock in 2002, UK. It should provide a broad spectrum protections against all isolates of the virus in all affected species by preventing virus carriage and the possible of shedding and transmission. It stimulates the level of immunity necessary to drive effective and long-lasting immune response. It should be inexpensive to manufacture and simple to administer. You should be mass administration is better than individual administration. In case of live attenuated vaccines, the vaccine and ideal vaccines shouldn't be able to revert back to its virulent strain. And it should have a long shelf life and heat stable. This is something that vaccine researchers are trying to look for. We want to look for vaccines that are able to live long, shelf life, or much more heat stable. Most vaccines currently, we have to keep it in the refrigerator, and a lot of vaccines failures is just due to loss of cold chain. So if researchers able to develop a much more better vaccine, they have long shelf life and heat stable vaccine, this is what we call it the ideal vaccine. And it allows discrimination between infected and vaccinated flocks. That would be great. Some vaccines that will be because this is one of the challenge of vaccination, to differentiate between infected and vaccinated flocks, and to provide strong level of maternal immunity, especially for the breeder farm. But please remember also, vaccines is all about risk and benefit. It's about balance between risk and the benefit. All this, we try to produce all this, but we try to reduce the risk and balancing with the benefit we gain with a lot of diseases. I will continue further with the vaccine. Okay, these are some examples of relationship between antibody titer and the challenge protection. As you may see, when chickens are being introduced into vaccine, it reduces the death, the egg drops, and the virus shedding. And these are the vaccine system in general. So it involves the few factors, which is the antigen, the vehicle for the vaccine, the delivery of the vaccine, and the use of adjuvants, which create the vaccine systems. Poultry vaccines technology, we can be further elaborated into live attenuated and kill vaccines in different combinations. So we have a monovalent vaccine, bivalent vaccine, trivalent vaccine, or much polyvalent vaccines. We also have kill vaccine that uses adjuvants. We also have antigen and immune complex vaccines, especially in case of infectious bursal disease. And we also try to have technology on the vaccine delivery. We have to compare between the single versus mass vaccination. And now the current one is more about recombinant vaccines, the use of recombinant vaccines commercially. I will explain further on this. For this, all of you may have known this, the comparison between live and kill vaccine. How do we want to decide, want to use kill or live vaccine? The advantage and disadvantages. For live vaccines, they are more possible to spread and mutate, and kill vaccine, they are much more stable and safe. Live vaccines, you can give single dose without adjuvant and neutralization by maternal antibodies. And for kill vaccine, they are, you will need to use adjuvants, and some of them you will need multiple doses. Both of them will produce variety of antibody responses. And for live vaccines, one of the main advantage of live vaccine, it can induce heterologous immunity, which means that it can induce mucosal immunity. On top of humoral immunity, they can also induce mucosal immunity, cell-mediated immunity, and the interferon production. In comparison with kill vaccine, they usually are poor in inducing mucosal, cell-mediated, and interferon productions. So when it comes to vaccine combination, okay, we in ideal vaccine, we try to develop a lot of different combination of vaccines, because if you notice in many of like vaccine producers of especially layers or broilers, they have like vaccine schedule almost every week. There's vaccines to give every week. By giving monovalent, much more bivalent or trivalent vaccine, you can protect against more diseases with less vaccination program. With this, it will reduce the handling of the animal and the stress of the animal. As you may know, vaccination procedure is a stressful period for the birds, especially if you have to give individually injection, IM injection, you have to catch them one by one. This is one of the stress factor. On top of that, vaccine itself can lead to development of immune response in the host, which can cause stress. Virus from the same family but different serotypes or from different family can be used for the vaccine combinations. Cross-reactivity between different serotypes depending on the availability of the common epitopes. And we are looking forward to the synergistic and antagonistic effects depending on the entry and application site of the virus or bacteria. Some vaccines, for example, when like in case of Marek's disease virus, they have like synergistic mechanism where if you combine some vaccines together, it will produce much more higher protections than is given alone. Secondly, antigen antibody complex is one of the technology in vaccine development. This is mainly focused more in the IBD, because IBD are much more the virus itself, the vaccine itself usually gets neutralized by maternal antibodies. This antigen antibody complex will answer the problem by what they did is they're combining the antibody with the virus together, and then what when all the epitopes are filled with antibodies, it hides from the immune response of the host during the early period of the life of the chickens. Because during the early period, the first 2 weeks, usually the chickens are having maternal antibodies. Okay, during that time, when the maternal antibodies wanes, the immune antibody complex will increase gradually secreted because the specific antibodies surrounding the vaccine strains also have a half-life. And also that when it comes to technologies, the use of adjuvants is also being investigated, adjuvants for inactivated vaccines. There we use a substance that enhance the immunicity of adjuvants, basically a substance that enhance the immunogenicity of the vaccines. Current adjuvants is usually the oil-based or aluminum salt, one of the common one. And vaccines are formulated in different emulsions types. So the mechanism of adjuvant is the mode of action is to prepare the antigen to persist longer and to induce co-stimulatory signals and enhance co-stimulatory signals of the immune system. And you increase the local inflammation of the area so that the host immune system will detect the antigen that you're coming in to engulf it, and non-specific stimulation of lymphocytes via induction of the cytokines. Hence, it's ideal to induce hyperimmune sera and high maternal antibody in DOC. This is some example, sort of the mechanism of adjuvant. Basically, the mechanism of adjuvant to enhance the immune response toward the toward the response of the vaccine, the intake of the vaccine itself. Next one, when it comes to vaccine technology, is the technology of vaccine delivery. The goal of the vaccine delivery technology is to identify optimal methods for presenting target antigens to the immune system in a manner that will elicit immune responses appropriate for protections. The vaccine delivery, there's a lot of vaccine delivery in poultry industry. We have a single vaccinations like individual subcutaneous injection, IM injection, or wingweb injection, or mass vaccination via spray or the use of drinking water. So these are some example: parenteral delivery through subcutaneous, intramuscular or wingweb, nasal delivery through use of the spray, ocular drops, oral delivery through drinking water, tablets, or feed-based vaccines. And we also have the technology of using the gel-based vaccine, where they drop some gels in the crate of DOC, and the small birds will pick up the vaccine. And the recent one, much more recent, is the in ovo technologies, where you are giving vaccines in the eggs at 18 days of embryonation. Here's some example. Some of you probably, those are working in poultry industry, are very familiar with this. Intraocular vaccinations, vaccinations via wingweb, via injections for wingwebs, for example, like fowlpox or AE, or subcutaneous injections like for Marek's disease virus, or IM injections for a lot of vaccines. We also have vaccinations via spray methods, either in the farms or at the hatchery. So when it comes to vaccine storage, it's very crucial to maintain a good vaccine storage to ensure that you don't have vaccine failure due to loss of cold chain. So most vaccine must be kept at 4 degrees Celsius. And it's not frozen, unless it's Marek's disease vaccine, should be kept in liquid nitrogen. It must be kept in dark place and avoid sunlight, especially for the live vaccines. Must be used as soon as possible after dilution, 2 hours post dilution. And they should follow manufacturer's recommendation, because each vaccine have different recommendation by manufacturers. And I would like to talk a little bit on advantage of vaccination in the hatchery. Many of you, I would suggest to opt for vaccination in the hatchery because it reduces the cost, especially in the broiler production. It's much easier when they are in the hatchery. You can do a mass vaccination with less labor. It works well with various vaccines, whether it's live vaccine, kill vaccine, immune complex, or viral vector vaccine, recombinant vaccines. It can be administration of vaccines is either by injections, in ovo or subcutaneous injection, or local application. And the hatchery vaccination is to ensure an early or improved resistance to disease. As you may know, when it comes to disease challenge, you want to make sure that chickens are well prepared or the immune status are well matured before they get challenged. So by doing hatchery vaccination, they get vaccinated before they even reach the farm. So this is just a picture of stimulation of an oral and nasal stimulation through local immune responses and systemic immune responses when you give vaccination through oral. And just now what I'm presented is more like what are the current one on the vaccine adjuvants and delivery. And now the researchers are looking forward for much more novel adjuvants and new delivery methods. Some researchers are working on a lot of new adjuvants, such as the use of plant adjuvants, saponin adjuvants, bacterial products, BCG, CPE nucleotide, as well as toxins, and various cytokines to develop into an adjuvant to increase the immune responses of kill vaccines. And we also have vaccine delivery system of new vaccine delivery system are being investigated over and over by the use of liposomes, ACE-COM immune stimulating complex, or use of virosome, virus-like particles, or ghost bacteria or empty bacterial membrane, bacterial arterial chromosomes, and encapsulation with biodegradable polymers. Okay, for just now, I've also spoke to you about the different types of vaccine currently available and in future prospects of the vaccines. Currently, we have conventional vaccine approach, which is the kill and live attenuated live vaccine. And also we also have recombinant vaccine based on genetic engineering technology. Some of it is already available in the market. Some of it is in the process of making available or in the testing periods. But do we actually need a recombinant vaccine? Yes, we need recombinant vaccines if they provide clear advantage over the existing vaccines. Again, when it comes to vaccine development, vaccine is all about risks and benefits. Again, when it comes to development of vaccines, you have to balance out the risk of new vaccines, recombinant vaccines, with the benefit they will get in general. What are the limitations of the current vaccine that can be answered by recombinant vaccines? Some recombinant vaccines are more heat stable or much delivery method, and the lot of limitations, like I told you earlier, when it comes to control of diseases, when it comes to current vaccine, there are chances of reverting to virulence, and recombinant vaccines will answer some of these questions. So this is some example of recombinant vaccine based on the genetic engineering technology. But not all of them are available. Like synthetic peptide vaccines is a chemically synthesized sequence of protein peptide that encodes for vaccine epitopes. Is by identify the peptide sequence that trigger the immune response, and they make a synthetic version of the peptides. And this usually have no risk of mutation and reversion. There are little or no risk of contamination by pathogenic and toxic substrates. And chemical manipulation could increase the stability or reduce unwanted side effects of the synthetic peptides. And there are also no antigen, number of antigen we can also increase because to be given is also increased because they don't need to be produced is also increased because they does not require the culture of a live microorganism. However, to my knowledge, is not yet available to poultry industry yet. And recombinant subunit vaccine is one of a disease that also not fully available in a poultry industry yet. It's similar to synthetic vaccine. Is basically it contains only the antigenic part of the pathogens. Next one is recombinant viral vector vaccine. This one is very common in poultry industry, especially I'm talking about more like a Malaysia situation and US situation. I'm not sure, but in India, probably you have a lot of regulations that restrict the use of some vaccines. But in Malaysia, we have a lot of recombinant vaccines currently being used in poultry industry by using a lot of vehicle system, using fowlpox, herpes virus, and adenovirus. we combine them. For example, the use of IBD in HVT or the herpes virus, or the use of IB in fowlpox. It's a combination of viral vector vaccines. And reverse genetic vaccines is another technology that is being conducted. It's an approach to discover the function of a gene that proceeds in the opposite direction of so-called forward genetic. Reverse genetic seeks to find the possible phenotypes that may derive from a specific genetic sequence during DNA sequencing. Researchers can change this sequence of the virus to their favor. And we also have recombinant bacterial vaccine. This is currently available in the market. Any bacteria that express the vaccine antigen or display the proteins on the surface of bacteria. There's some we can insert into the chromosome of the bacteria as well to express the vaccines. And DNA vaccines, this is sort of quite new. Is not very new technology. It's been a while. It was first introduced in 1993 for poultry, especially against avian influenza. It has been developed against several viral, bacterial, and protozoan diseases. And in US, his first commercialized DNA vaccine was against H5N1 in chickens, has been conditionally approved, which means like there are very strict usage conditions to use these vaccines by USDA, which targets highly pathogenic H5 influenza. And the more recent one also is like the virus-like particles by using empty virus capsids and expressing vaccine antigens. This is soon to be available. So and then we have to ask ourselves, what makes recombinant vaccine attractive? Recombinant vaccines are usually the one that has passed the regulation, usually safe and effective vaccines. Example, inactivated vaccine that able to induce mucosal or cell-mediated immune responses, vaccines that able to induce appropriate or required immunity. A single vaccines may protect against several different agents. Some recombinant vaccine, because of they put few epitopes of antigens inside there, so you can protect against several different antigens. And effective in presence of maternal antibody, vaccines that induce long-term immunity, vaccines that are able to induce rapid response, especially if you are in the emergency situation, there's an outbreak coming in near you. Homologous live vaccines against pathogenic field strains, or designer vaccines marker, zoonotic diseases and for disease eradication. And universal vaccines, some of it maybe have potential to be universal vaccines, especially in avian influenza vaccine that can protect against various species, and also vaccines that can be integrated with the existing vaccines program. So these are the things that they look for when it comes to development of recombinant vaccines. So when we talk about vaccines, we always talk about vaccine efficacy and protective immunity. That is very important to any farmers or those working in poultry industry. And then to know the vaccine efficacy and protective immunity, you have to perform a challenge study, is to determine the outcome of infection immunity. The challenge study is to determine the balance between infection and the immunity. And usually, what you have to do in challenge study is you compare vaccine efficacy of vaccinated and the control non-vaccinated groups. You measure a lot of parameters like production of antibody, or some experiment will also measure cell-mediated immunities. You also measure morbidity rate or mortality rate, immunosuppression, example, basal body or thymus weight, like whether the vaccine, because the vaccine in itself can also induce immunosuppression. So challenge study is when you evaluate the vaccine efficacy and the side effects. Virus shedding, the oocyte counts or celiostasis, because if possible, you don't want a vaccine that also, you want a vaccine that also prevent the shedding of the viruses. And also disease transmission to sentinel and susceptible bird. This is also related with virus shedding. If you put naive birds in the farm, in those infected birds, does it transmit into the knife birds. So again, a vaccine is a complementary approach to biosecurity. Most vaccines are almost 100% effective in controlled experiment where it's able to induce robust immunity. However, you have to consider a lot of factors. Various factors influence vaccine efficacy in the field. When you do an experimental vaccine challenge study in experimental condition is totally different when you are do a control challenge in the farm. In the field, the major challenges during vaccinations are making the vaccines easier to apply, less expensive, and much more efficacious. So the outcome of infections, how infection develop usually comes from hosts, whether the hosts are healthy enough or there's a lot of factors with the host, the agent, and as well as the environment. So what could influence the vaccine efficacy? First is the factors associated with the vaccine itself. Different serotype or subtypes or level of crop protection of the vaccine. Some viruses have many serotypes. I'm talking about more like infectious bronchitis. If you vaccinate with different serotypes, you may not get the efficacy, the protection with that serotypes. Live vaccine with varying virulence and also the use of different vaccine antigens. Factors associated with vaccine administration. For example, the handling of certain live vaccines is important in influencing the vaccine efficacy because live vaccines have to be administered properly. If you don't administer properly, they might die and you may not get the immune response that you want. And also quality check of the vaccine diluents. This, like for example, in Marek's disease virus, if you did not mix well the vaccine, you will have a very low efficacy. Route of vaccination and dose vaccination plays important role is when it comes to efficacy of vaccine. And next one is factors associated with the birth of flocks. Okay, but the level of maternal immunity, does it interfere with the vaccine? Okay, for example, in case of infectious bronchitis, infectious bursal disease virus, does the bird have immunosuppression? If they have immunosuppression, they cannot produce the immune response against the vaccines, as well as the stress is related to immunosuppression. The bird's already infected with the disease, which becomes redundant to vaccinate anymore. And then the genetic of the bird itself. Some birds are susceptible to the virus or to the pathogen. Some birds are much more susceptible to another pathogens. And management conditions, hygiene practices, and the biosecurity. When it comes to establishing a vaccination program, there is no standard vaccination program which can be applied to all farms. If you may have already know, if you go to different farms, although they are site to site, their vaccination program are different because they cater to the needs. Each farm must develop its own specific vaccination program based on the following factors. The type of production, which is whether it's broiler, layer, or breeder. For broiler farm, you want to be as cost effective as possible. And in layer and breeder, you want to protect the health of the birds, as well as for breeder, you want to induce maternal antibodies for the progenies. The health status of the farm, which disease have already been encountered on the farm, or the health status of the zone or country in which the farm is located, what diseases are present in the vicinity of the farm, and which ones are the potential threats. These are the things that you have to consider when you develop a vaccination program. Based on the overall level risk of each diseases, various modifications to the vaccination program may be envisaged. So these are the things that you consider basic of vaccination in poultry. The requirement for a good immune response. And then basic vaccination, the elements in vaccination programs, number of vaccination, you have to consider how many times you have to vaccinate them, what type of vaccine do you want to use, whether it's live vaccine or kill vaccines, what route of vaccination that you want to use, whether you have enough labor to use different vaccines, interval between the vaccination, and the age of first vaccinations. All of these are important when you're planning a vaccination program. You want to stimulate and maintain the protective immunity and develop high immunologic memory. That's the objective of immunity. And you may notice you will have vaccination failure in the farm. And then that's when you have to revise back what is the problem. So when it comes to vaccination failure, you have to consider maybe some animals unable to respond to it due to immunosuppression diseases. For example, like if the chickens are already infected with infectious bursal disease prior to vaccination of another disease, or you made the prior to vaccination, it may not be able to produce an immune response appropriate to that vaccines. Presence of passive immunity will interfere with the vaccines. Poor vaccine storage, wrong vaccination techniques, expired vaccines, and vaccination of infected and sick flocks. So from what I've saying here and there, you may notice that vaccine technology is a continuous evolution due to evolution of diseases. I will take an example. My expertise is more like you may have known before. My expertise, my PhD was actually on Marek's disease. As you may notice, this is some history of Marek's disease. It was first described in 1907 as polyneuritis, and as poultry industry intensifies, it caused high increase of losses in 1960s, and over time, vaccine has been produced since then. In 1969 for HVT, 1980 has been used in USA, and CBI-988 has been used in 1990s. This is for USA example, but they are being established a lot earlier. So this is the vaccine era for Marek's disease virus. HVT was being produced, HVT SB1 and Rispens being used later at the age. This for US situations. In US, they noticed that when we collected samples, there's a study by Dick Witter. They collected samples over the years. They noticed that the virus are evolving. Okay, in 1960s, when the first isolation of the virus, they are under the virulent strain, virulent Marek's disease virus. As time goes by, in 1980s, they detected they are more on the very virulent strains. And now, in 1990s until now, we are having a much more virulent strains in the industry, very virulent plus Marek's disease virus, which requires us to always prepare ourselves to production of new vaccines to the new challenges. And they have said also, this is a US situation, when 1960s, when HVT is being introduced to control the virulent strain of Marek's disease virus, they control it for 10 years, and there comes the very virulent strain. And then they use the bivalent vaccines to control it. For about 10 years later, a new evolution emerges, leads to the production of very virulent plus Marek's disease virus. And since then, they use Rispens in the market and they control Marek's disease virus. And now we are not sure whether these diseases are getting more evolving or much more evolving or not. And there has been associated, some study has associated that maybe the use of vaccine itself is driving the virus to become more virulent. This is some of the things that has been discussed before. For Marek's disease vaccines, we some examples. We use Marek's disease vaccine, serotype 1, Rispens. To my knowledge, if I'm not mistaken, India is not using Rispens. Okay, serotype 2 SB1, serotype 3 HVT, and we also have recombinant vaccines with the use of HVT. And the protocols for common Marek's disease vaccine is either day-old vaccination or in-ovo vaccination. We also have revaccination program, and it has shown that revaccination program can produce much better protection, and also double dosage protocols. Over the years, we have tried to improve Marek's disease vaccine protocols by, you may have seen that we produce the better vaccines over the years, from HVT, from bivalent vaccines through Rispens, and and on top of that, we implement revaccination strategies, and after that, we implement the in-ovo vaccination. So if you can see over years, the vaccination strategies keeps evolving, which requires us to find more and more vaccination in the future. So this is a future of Marek's disease vaccine. For recombinant vaccine, there's some of it has been developed through the gene deletion of serotype 1 vaccines, some of the gene deletion. and also insertion of REV-LTR inserts and the use of DNA vaccines. And right now, we're also looking forward to vaccine protections against late Marek's disease immunosuppression. This is also one of my research interests. Try to look, because currently all the Marek's disease vaccines are protecting against development of tumor, but is that none of the current Marek's disease vaccine are protecting against the development of immunosuppression. So this is the prospects of future Marek's disease vaccines that we're looking forward to. And when it comes to vaccine efficacy in general, this before I finish it, because in general, you have to consider one thing, which is the immunosuppression. Immunosuppression is your enemy to vaccination. So you have to reduce the immunosuppression before for any vaccination program, because immunosuppression will lead to failure of your vaccination program, whether to due poor vaccine-induced immunity or increased susceptibility to infections. In conclusions, current poultry vaccines and delivery systems are quite effective in controlling the current diseases. However, the pathogens are moving targets. They are zoonotics, they produce more variant strains and more virulent strains and more immunosuppressive strains, and which requires us to keep looking for a new vaccine strategies. Vaccine is all about risk and benefits, protections against infections. We want to reduce the clinical diseases, or we want to reduce the virus shedding and disease transmission. Recombinant vaccine is making its way in poultry industry. The more recombinant vaccines is being produced now and in the market, recombinant vaccines should address the limitations of current conventional vaccines, and vaccines requires continuous improvement. Thank you. Last but not least, before I end, I would like to just promote a little bit. Malaysia will host WVPA Congress in 2023, World Veterinary Poultry Association Congress in 2023. If we are over with this COVID situation, hope by 2023 we are over with this. We are having like a lot of problem with COVID. So I would like to invite all of you to come to World Veterinary Poultry Association Congress in Malaysia. We'll be in the Borneo part of Malaysia, which is Kuching, Sarawak. With that, I'll end the presentation and get back to Dr. Vital. Thank you.
Thank you, Dr. Nick.